Hey guys, so we're ready to start looking at slightly harder binomial expansions now. In particular, we are going to be looking at expansions of the form 1 plus ax to the power of n. So we are now attaching a constant or a coefficient to our x term that is not just equal to 1. So this does alter our formula a tiny bit, but it's nothing ridiculous. So, when we were looking at 1 plus x to the power of n, our formula was 1 plus n choose 1 x plus n choose 2 x squared plus n choose 3 x cubed. And that pattern continues all the way up until we've got just our single x to the power n term. Now, all that happens to this formula when we have a coefficient on the x term is that x, or the x's in the formula, become ax. So the formula for 1 plus ax to the power of n is just 1 plus n choose 1 times ax plus n choose 2 times ax all squared. So you would get a squared x squared plus n choose 3 ax cubed. So n choose 3 a cubed x cubed. And then that carries all the way up to our power of n term, where we're going to get a to the power of n, x to the power of n, or ax all to the power of n. So, as I said, it's not really that scary. Doesn't make things too much more difficult, although we are about to see negative numbers and also fractional numbers too. So, let's get cracking. Okay, so first example then, we're going to look at the expansion of 1 minus x to the power of n. So, using the formula on the previous page, we would have 1 plus n choose 1 times minus 1x. So, times minus x. Then we're going to have plus n choose 2. This time it's going to be minus x all squared, and then plus n choose 3 times minus x cubed. So times minus x cubed, like that. And then this pattern is going to continue. So we're going to have our plus, dot, 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 and then plus all the way up to minus x to the power of n. So if we tidy this up a little bit, we've got 1 plus, well, it's actually going to be minus n choose 1 x. Okay, now that's just because we had n choose 1 times minus x, so we can write that as minus n choose 1 times x. And then we're going to have, well, in our next term, we've got minus x all squared. So that's going to give us positive. So this time, we've got plus n choose 2 x squared. And then we're going to have, well, minus x cubed, which gives us a negative x cubed. So now we've got minus n choose 3 x cubed, dot, 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 all the way up to minus x all to the power of n. So what can we notice here? Well, the coefficients are exactly the same as 1 plus x to the n, except for negative signs. So we can see here every other term is negative, so alternating terms, and it's the terms with the odd powers of x that are negative. So we've got minus n choose 1 x, minus n choose 3 x cubed. So if n is even, then we have positive terms. So if n is even, then our final term minus x to the n would be positive. If n is odd, then minus x to the n is going to be odd. So that's our first one. Hope you followed that alright. Okay, second example, and so we want to expand fully 1 plus 2x to the power of 4. So, let's do just that. So, here then, a is 2. So, we are going to get 1 plus 4 choose 1. 1 plus 4 choose 1 times 2x plus 4 choose 2 times 2x all squared, and then plus 4 choose 3 lots of 2x cubed, and then finally we're going to get for our last term, you can think of it as 4 choose 4 if you want, but the last term, or the coefficient of the last term in terms of the binomial expansion coefficients is always just 1. Any number, choose itself, is just 1. So our final term is just going to be plus 2x all to the power 4. So if we sort that out, we've got 1 plus, well, 4 choose 1 is 4. So we've got 4 times 2x, which is going to give us 8x. Now 4 choose 3 is, sorry, 4 choose 2. 4 choose 2 is 6, and 2x squared is 4x squared. So we've got 6 times 4x squared. So that's going to give us 24x squared, and 4 choose 3 is 4, and then we've got 2x cubed, so that is going to give us 8x cubed. So we've got 4 times 8x cubed, which is going to give us 32x cubed, and then our final term, 2x to the power of 4, well, 2 to the power of 4 is 16, so we get plus 16x to the power 4. So there is our expansion of 1 plus 2x to the power of 4. Okay, next example, we want to expand 1 minus 3x to the power of 5. So here, a is minus 3. Now instead of playing around with chooses, I'm going to use Pascal's triangle to get my coefficients. So, Pascal will click one of those, 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, and then 1, 5, 10, 10, 5, 1. So the coefficients I want are 1, 5, 10, 10, 5 and 1. So now we're going to use the formula with a equals minus 3. So we are going to get 1 plus 5 lots of minus 3x plus 10 lots of minus 3x all squared plus 10 lots of minus 3x all cubed, and then plus 5 lots of minus 3x all to the power of 4, and then for our final term we're going to get plus minus 3x all to the power of 5. So now let's go through and simplify that. So we got the 1. Then we've got plus 5 lots of minus 3x. 5 times minus 3 is minus 15x. Then we've got plus 10 lots of minus 3x all squared. Now minus 3x squared is positive 9x squared. So we've got 10 times 9x squared. So we've got plus 90x squared. And then we've got plus 10 lots of minus 3x cubed. Now minus 3x cubed is minus 27x cubed. So we've got 10 lots of minus 27x cubed. So that is minus 270 x cubed. And then we've got plus 5 lots of minus 3x to the power of 4. Now minus 3 to the power of 4 is minus 3 times minus 3, which is 9 times minus 3 times minus 3. So it's 9 times 9. So we've got 5 lots of 81 x to the power of 4. Now 5 times 81 is 405. So we got 405 x to the power of 4. And then our final term, well, we got plus minus 3x to the power of 5. So that's an odd power, so we're going to get a negative term. Now minus 3 to the power of 5 is 81, which was minus 3 to the power of 4, multiplied by minus 3. So that's going to be minus 243 x to the power of 5. And there it is. There's our expansion in all of its glory. Try and get it so you can see all at the same time. There we go. Cool. Okay, last example for this video then. I was going to put fractional values of a in here too, but we'll just do that in the next video. So, here then, we want to find the first 4 terms of 1 minus 7x to the power of 10 in ascending powers of x. So, in ascending powers means we're starting off with the lowest power of x and working our way up. So, we're not going to use Pascal's triangle for this one. No. So, our expansion then is going to be, well, it's going to be 1 for our first term. Then it's going to be 10 choose 1 times minus 7x, like that. Then it's going to be plus 10 choose 2 times minus 7x all squared. So that's 3 terms, we need one more term. So our fourth term is going to be 10 choose 3 times minus 7x all cubed. Like that. So now we just need to simplify. Okay, so we got 1. Then we've got 10 choose 1. Any number choose 1 is that number itself. So 10 choose 1 is 10 times minus 7 is going to give us minus 70x. And then we've got definitely a job for our calculators. So 10 choose 2 is 45. Minus 7x squared is going to give us positive 49x squared. So 45 times 49 gives us 2,205x squared. And then for our final term, well, 10 choose 3 is 120 minus 7x all cubed is going to give us minus 343x cubed. So we need to work out 120 times minus 343, and that is going to give us minus 41,460x cubed. So there are the first 4 terms of our expansion of 1 minus 7x to the power of 10. Okay guys, that's it for this video. In the next one, we will look at doing these when a is a fraction. It's going to be fun. See you there.